Good morning, everyone. Welcome. Welcome to the session. A very warm greetings from Mercy Technologies. Thank you for giving your time. We promise that you'll surely be learning something new and something interesting today. Let's go back. So what is the today's agenda? Today's is very simple. For any program that we try to achieve, there are different ways. And most importantly, people say I have achieved this functionality using iterative approach, using a recursive approach. So these are two important things, guys. In programming, we achieve looping things by using either iterative or a recursive approach. So today we are going to dive deep and find out, is iterative a better approach or is recursive a better approach? And how we are going to do that? By calculating time and space complexity by taking a particular example. This is going to be very interesting, provided you put all your attention over here. As I have mentioned previously, what I like to add here is, it's good if people have a pen and paper with them. It's good if people have pen and paper with them. Even if they don't have, that's fine. Even if they don't have, that's fine, because let's make it a little bit more lively. This is the I'm telling you this, guys. Next time when you try to join, if you have a pen and paper with you, it will be even more lively and will be great, because you can take the running notes and you can answer the problems that I'm asking in the middle of the session. Let me go back. So to specify or to find out if a program is good or bad, we need to find its efficiency. There are two ways of finding efficiency of a program. In computer science, we specifically deal with time and space complexity. So what is time complexity? Time complexity is a very simple definition. The number of steps that a program takes in terms of input given. For example, let's say you have to print 10 numbers, 10 numbers. So you'll give the input as 10. So which means your loop runs for 10 times. So program depends on the amount of input that you're giving, right? For example, you take 1 unit. For every loop that you iterate, it takes 10 units. So if n is equal to 10, which means it takes n units, right? So very simple, very straightforward definition. Time complexity is nothing but the number of steps that a program takes in terms of input, which we give. Now, what about space complexity? Let me give you a very simple definition for space complexity as well. Space complexity is nothing but the extra space that the program takes in terms of input given. So I'd like to emphasize this thing, guys. This is an extra space that the program takes in terms of input given. So what is this extra space? For example, let's say your program have given an input of 10, and since you have given an input of 10, say your program is consuming 10 bytes. And if you have given the input of 20, it is consuming 20 bytes. Or if you have given the input of 30, it's consuming 30 bytes, right? So this is the extra space the program takes. And so straightforward, the base condition, guys, like, so let's say a program is not dependent on the input. Your program is not dependent on your input, which means your program is having order of 1 time complexity. If your program is dependent or on your input, which means it grows, your algorithm grows on your input, which means it's having a time complexity directly proportional to the input that you're giving. Now, let's try to dive deep into these. Are very two simple definitions that we have learned just now. Let's remove all the drawings. Now, let's go. So, our agenda today is to find out is iterative approach a better approach or recursive approach a better approach? And how are we going to find out, guys? We are trying to find out by saying by calculating the time complexity and space complexity. We are trying to calculate a time complexity in iterative, time complexity in recursive, time space complexity in iterative, space complexity in recursive. And based on this table, let's decide which approach is a better approach, right? We are taking here examples, guys. I'll not take too much of your time. We are trying to take examples. One is factorial and second is Fibonacci. Factorial is simple. It is understood. This is a basic program. Fibonacci series is a program. Understand. Let me try to give you a background of this factorial. Okay, and let's start coding, and after that, let's start calculating time and space complexity. Right now, let me import. One second. First, we are trying to deal with the factorial program. What is a factorial? Let me import a diagram so it makes you easily understand. Uh-oh, is it stuck? It shouldn't. Let me directly open. Okay, good. It loaded. So this is the factorial, right? So what is the factorial of 1? It is 1. This is the base condition. Factorial of 2. Factorial of 2 comes to 2 into 2 minus 1 is equal to 2. So what is factorial of 3? It is 3 into 3 minus 1 into 3 minus 2. So which is 3 into 2 into 1, which is 6. So similarly, the 4 factorial is 24. Similarly, 5 factorial is 120. Okay, this is how the calculation goes. It is n into n minus 1 into n minus 2 and so on and so forth. The base condition, the factorial of 1 is 1. All right, this is what the factorial is, guys. For example, let's say the input given is 5 and interviewer asks us what is the factorial. You say 120 based on this calculation. Now, straight away, let's go into the code, guys. Let's go into the code. Here, our emphasis is not trying to write the code, but trying to find the space and time complexity, right? As I told you, there are two approaches. One is an iterative approach, and second is a recursive approach. Let me try to open the iterative approach for you. Okay, iterative approach, the code is something like this. Okay, this is the method. This is the method. Okay, so now what happens? There is a base condition. If n is equal to 0 or n is equal to 1, then you're returning 1. What is this 1? This is the factorial. The factorial of 0 or factorial of 1 is 1. Then what you're saying, what you're doing on line number 12, you have taken a variable, the local variable called result, and you're trying to initialize that with 1. And here what you're doing, you're iterating based on the input that you gave. You are iterating and finally you're returning the result. Right, let's try to I have given a hard-coded value which is 5. Let me try to run this code. Run as Java application, proceed 120. Right here what it says, the output that we got is 120. Code is not visible is what the people say, right? I just want the other people, maybe you refresh your screen. Uh, Now it's visible. Guys, is it not visible from beginning? Is it not visible from beginning? Is it not visible from beginning? Oh, okay, okay. Sorry for that. Sorry for that. I think there is some technical glitch. Since it is not visible from beginning, let me come out. Let me come back. Let me come back very fast. Let me come back very fast. Okay. So let me go back. Guys, just a confirmation. Just tell me what you're able to see on my screen. Just tell me what you're able to see on my screen. You can send me a screenshot. Great. Okay. Okay. Perfect. Perfect, guys. Now I think you should be able to see. Let me go very fast until this part because let me not take most of your time. So our actual approach that we are trying to find or to achieve with this session is try to calculate or try to find is iterative approach a better approach or recursive approach a better approach, right? So which one is better? Let's try to find out in this session. So I was telling you what is the definition. The definition of a time complexity is the number of steps that the program takes in terms of input given. So what about space complexity? The space complexity is nothing but extra space that the program takes in terms of input given. The extra space that the program takes in terms of input given. These are the definitions. Let me come back. Okay, what we are trying to learn today. So what we are trying to is find out is an iterative approach a better approach or recursive approach a better approach, and how we are trying to find it out, we will be finding out by filling this table. Today our agenda is to fill this. What is the time complexity in terms of iterative approach for a factorial, in terms of factorial space complexity for the same. Based on the values that we fill in this table, we will find out which approach is better. So after taking the examples of factorial, let's come back to Fibonacci series, which is little bit more complex when compared to factorial, which is little bit more complex. And we'll try to fill this table and finally conclude, is iterative approach a better approach or recursive approach a better approach? And what are we trying to achieve by this? We will be getting a satisfaction to find out which approach is better and when to use which approach, right? Let me go back. So this is what, tell me guys if you are able to see the code now. I'll be opening up Eclipse. Tell me if you are able to see the Eclipse right now. You should be seeing screen like this. Perfect, perfect. I think people are able to see the code. So what is a code for calculating factorial? Oh, before that, I wanted to say this one as well. Erase everything. Okay. Let me import the same diagram again. So you should be able to see. Just you're able to see now, guys. I'm receiving messages. I'm trying to explain this. So I think there's a conflict. So that's the reason. It's okay. So you should be seeing a diagram which explains what is okay. I see that in the screenshot. I see that in the screenshot. So now let me explain what is the factorial for 1. The factorial for 1 is 1. The factorial for 2 is 1 into 1 in 2 into 2 minus 1, which is 2. The factorial for 3 is 3 into 3 minus 1 into 3 minus 2. That gives you 6. Factorial for 4 in the same calculation gives you 24. It gives 120 in terms of 5. So this is what a factorial is. This is a simple input and what is the output that we are expecting, right? And what is the output we are expecting. Now, let me show you the code for this. So what is the code that I've written? I've taken the base. Okay, one more thing. The factorial for 0 is also the factorial for 0 is also 1. Okay, let me go back to the code. So what is the base condition here? The base condition says on line number 9, it says if n is 0 or 1, you return 1. This is the base condition. And I've taken a local variable which is result and I'm initializing that to 1. And here I'm iterating over the for loop and finally trying to find out the result and returning that result to this method. If you see my first and second session, guys, so I told you that having the proper method signature is very important. Let's say you don't write all this code. You don't write all this code. When an interviewer asks you to write what is the factorial, try to find the factorial. So I should have a return type properly. I should have a proper name. I should have proper input, and I should have the return condition. So after that, this is the first point. And with this, you can impress the interviewer half the way. And after that, if you remove this, is called as a base condition. So this base condition is also very important factor. The reason is it will reduce your null pointer exceptions. Here we are not dealing with any object, but there are places where you deal with objects. And when you write the base condition properly, you will be gone with half the errors because you'll be not having any error index out of bound exception. You'll not be having null pointer exceptions, right? This is very important, right? This is a very simple code, guys. I have taken a result and I'm initializing that to 1. And after that, I've taken a for loop. It is starting from 2 because for 0 and 1, we already have a condition. It is starting from 2. And what I'm doing here, result is equal to result into I. So the same thing that I'm doing in my previous calculation, right? When I try to run this program, so what is it giving me? What is it giving me? It is giving me an output of 120. So what is the input we have given? We have given the input as 5 and it's giving the output of 120. This is what we have seen over here. Same program we have written. Now let's try to calculate the space and time complexity for this piece of code, right? If you have a pen and paper, guys, just I don't know, like maybe you will be always, you might be having an approach of calculating the space and time complexity already. What I want you to ask is what is the time complexity of this piece of code. Could anyone start pinging me? I try to analyze. Let me try to analyze what is that space complex, what is the time complexity for this piece of code. I'm waiting for your reply. What is the time complexity of this code? What is the time complexity of this code? Yeah, I see replies. perfect. I see replies. I saw one person who replied order of n minus 2. Maybe I think what he thought was we are not including 0 and 1, so we are removing 2 iterations. But the thing that I want to say, guys, is but the thing that I want to say here is, if you see my previous class, I told you whenever it is n minus 100, n minus 1000 also, this 1000 is called as a constant. Whenever we are having an equation, something like this, right? Let me put an equation, something like this. When we have an equation something like this, when f of n is equal to n square plus 2n plus 3. So what happens here? This is a constant. We need to remove that. Here this n is less in comparison to n square. So this is also neglected. So here it becomes order of n square, right? What is the maximum that we have in our equation? That becomes our time complexity. That becomes our complexity. So here in case what you say, order of n minus 2. Here what happens, this 2 is a constant, n is bigger, so what happens, this is order of n, right? But let's try to find out what is this order of n and how did we achieve that. I'll show you a small formula. I'll show you a formula for that, right? Let me open this up. So if you can see here, what I do here is what I'm trying to do here is, so we have an iterative formula over here for calculating time and space complexity. This is the time complexity. What is the iteration? Number of steps in terms of n. Number of steps in terms of n. So what is the number of steps that we have in our program? So let's say we have 10, then we have how many steps? We have 10 steps. Okay, we'll ignore these two. We'll have 8 steps, right? If you have 20 as the input, you have 18 steps. But that is a factor. The 2 is a factor. Let's consider that also to be n. If the input is 100, you will be doing this for loop for 100 times. So what our formula says? Our formula says number of steps in terms of n. So which means number of steps if the input is 100, number of steps are 100. If the input is 1000, number of steps are 1000. So what happens? Because of this, what we conclude the time complexity is order of n. Let me try to enter that in this table. What is time complexity for factorial? It is order of n. We achieved it. Now let's try to find out the recursive approach. What is the recursive approach? I have written the program for recursive approach as well. This is the recursive program. This is a very simple code. This is a very simple code. Okay, this is iterative approach and this is a recursive approach. This is the recursive approach. What it says, this is the base condition again, n is equal to 0 or n is equal to 1, you're returning 1, or else returning n into fact of n minus 1, n into fact of n minus 1. Let me try to explain diagrammatically how this works, how this recursion works. Let me try to open a Microsoft whiteboard. So what is this code? This code here is this. Let me paste it. I pasted it here. Okay, I pasted it here. So what it says, this is the base condition. We are not bothered about it right now. This is fine. And now this is our actual recursion. So how do we calculate the number of steps? Let's say the input, what I'm taking, n is equal to 4. So when I take n is equal to 4, f of 4. What is f of 4 doing? F of 4 has come into this code. Finally, it is calculating f of n minus 1, fact of n minus 1. It is calling a method, the fact method, with input as 3. Now this is internally calling with input as 2. This is internally calling the input as 1. So what happens when n is equal to 1? It returns 1. So what is it returning? This is returning 1 back to f of 2. And what is this f of 2 doing? It is calculating, it is multiplying. If you see this statement, if it is multiplying the n with this 2, so what happens? The calculation here goes 2 into 1. So the answer for this is 2. Now this 2 is again getting returned to f of 3. So what happens? Here it is 3 into the result from previous step is 2, which is 6. Now again we are returning it back. So what it says? We have returned it, and is 4 into 6 is equal to 24, right? Is equal to 24. So this is the number of method calls we are having. The number of method calls, if I mean here fact. So this fact is nothing but this method, right? How many method calls we have? 1, 2, 3, and 4. So total number of method calls are 4, right? This is a calculation. This is a conclusion we are making. Let me go back to the formula that I have formulated. What it says, a recursive approach, if we need to find the time complexity, what it says, number of recursive calls into time complexity of each call. Ignore the recursive call. Based on this formula, the number of recursive calls are how many? The number of recursive calls are 4, and what we are doing, time complexity of each call. What is the time complexity of every call here? The time complexity of every call is nothing. It's like you're not having any loop inside this fact, right? Inside this fact, we do not have any other things that we are doing. So the time complexity of loop will become order of 1, right? And we are ignoring the actual iterative or the actual recursive call in it. So what happens? The input is 4, so which means input is 4, number of steps are 4. So which means input is 10, number of steps are 10. Which means what we conclude, the time complexity here is 4 when the input is 4, time complexity is 10 when the input is 10, so the time complexity is n when the input is n, so which means the time complexity is order of n. Simple. Now let's try to fill this table. So what is the time complexity in terms of recursive approach? It is order of n. I think you guys got how I calculated in recursive, how I calculated the number of recursive calls. The number of recursive calls here, as I told you, are 4. That is why the time complexity is order of n. So until now, we are not able to conclude is iterative approach a better approach or recursive approach a better approach, because both iterative and recursive approach both have the same time complexity. Now let's move to space complexity. So what is space complexity? As I told you in my presentation previously, space complexity is nothing but the extra space that is consumed by your program. The extra space that is consumed by your program. Okay, now let's see. This is the formula. So you come to this formula. You come to this formula of finding the space complexity in terms of iterative approach. In terms of iterative approach, so what is the iterative approach for factorial? This is the iterative approach for factorial. What is the extra space that it is consuming? For example, let's say in this for loop or in this method, are you consuming any extra space? Do you have a hash map? Do you have an array? Do you have anything that is growing? Because let's say I'm giving the input as 1000, are you creating 1000 extra spaces in your program? You're not creating absolutely no extra space based on your input. So what happens, the only space that is being used is this I, and this I is nothing but it's a local variable. That's fine, but your program's space is not increasing because you are increasing the input. So that is the reason what happens, the space complexity becomes order of 1. Order of 1, right? The reason why it is becoming order of 1 is because in iterative program that we have written, we do not increase the space based on input that we are giving. So guys, now let's try to find out the space complexity in terms of recursive and conclude which approach is better. Now, in terms of recursive, what is the formula? Maximum length of stack into space complexity of each call, ignoring the recursive call. Let me try to do the same drawing for you so that you will be in a position to understand it better, right? Let me try to copy this and go back, right? This is our program. This is our program. This is our recursive program to achieve what is space complexity. Now, guys, you're able to hear me properly and you're able to get everything properly, correct? No audio, no audio. Please tell me, guys, if you are able to follow me properly. Please reply. Okay, great, great. For the person who has replied me that there is an audio problem, I recommend please check your internet connection or please check your headphone, right? The other people are able to hear it properly, guys. Now, what is our thing now? What should we do now? Yeah. So what should we do now? As per our formula, we need to find out the length of stack. So what is stack? So for any method call, for example, you write some program and when you write a program, when you're trying to call a method, internally in the memory, there is a record which gets created inside the stack. That record is called as an activation record. Let me try to draw it. This is the stack. When you're trying to call something recursively, this fact of n-1, there are multiple calls which happen, and for every method call, a record gets created. In this case, when n is equal to 4, f of 4, a method call happens, and this method call is called as activation record. This is called activation record. So what is this called? This is called a stack. I'm not speaking about recursive approach, but in general in programming, this is called when you have a class which has multiple methods, internally a stack gets created, and when a stack gets created, sorry for that, some pop-up came. When a stack gets created, that stack internally has this method calls, right? Here in our case, first there is a call for f of 4, and there is a call for f of 3, and there is a call for f of 2, and there is a call for f of 1, and there is a call for f of 0. But as we have previously mentioned, how was our method call? Let me try to write the method calls. So there is this f4, it calls f3, this calls f2, this calls f1. But as per our base condition, what is this f1? When n is equal to 1, then you're returning 1, right? Then you're returning 1, which means this is a base condition. So from here, it tries to go back, it tries to call itself recursively. So let me come back. What happens when f equal to 1? It's execution. Its execution, f of 1's execution completes because it came into this base condition. So what happens? This execution is completed. Now it comes back to f of 2. So what happens? Again, it goes, its calculation, its execution is completed. And after this, f of 3's execution is completed, f of 4's execution is completed, right? This is how the execution is completed. The moment the execution is completed, the activation record gets distracted, or maybe it gets destroyed, and moment the method call ends, your whole stack will be destroyed inside the memory, so this is just for your basic, guys. But now let me try to make you understand what we have achieved with this one. So what we have achieved is we try to find out the length of the stack. What is the length of the stack, guys? The length of the stack is 1 2 3 4 4. Let's say your input is 20, the length of the stack is 20, right? So what we have concluded, the length of the stack is directly proportional to the input that we are giving. So the length of the stack is n. So let's try to find out or calculate based on the formula that we have given here. What it says, max length of stack. Max length of stack is 4 when the input is 4. It's 10 when the input is 10. It's 20 when the input is 20. So that is why the space complexity will become into space complexity of each call. Every call is not consuming any extra space. So this part becomes order of 0. And the max length of stack will become order of 1. We are ignoring the recursive call. So the space complexity here becomes order of n. So guys, we have concluded by using iterative approach, the time complexity is order of n, space complexity is order of 1. By using recursive approach, time complexity is order of n, space complexity is order of 1. So what is the conclusion? The conclusion is iterative approach is better, right? Based on what? When you use a recursive approach, the space complexity is more. That is why the iterative approach is better. Guys, clear? Clear for everyone? Clear for everyone? Great, guys. Great, guys. So what is our conclusion? In our first example, which is factorial, recursive approach is better than iterative approach is better than recursive approach, because recursive approach takes order of n. But just a word of caution now, guys. Just a word of caution is, we have a concept. I have written the program like this. I have written the program like this in terms of recursion. But there are even better ways of writing programs, guys. But this is the basic way anyone codes in terms of recursion. There is a concept called memoization. Using this concept, you can reduce the space complexity also in terms of recursion to order of 1. But it's very hard to even cover this concept now because of time constraint. We can learn that in our master course, guys. By using memoization, we can even bring our iterative approach, our recursive approach, space complexity to be order of 1. Guys, I think we are done with half of our investigation, and we are done with half of our conclusion as well. Good, guys. I think we have filled up half our table. In Factorial, we have filled up the total table. I just want to ask at this time, is the concept clear for you? Any doubts? I'm waiting for your reply. Please reply. Have you understood? Have you understood? See, good to see people are replying. Requesting everyone to reply, because this is the first half of the session, guys. When we go to Fibonacci series, it becomes even more interesting. You should be clear with this. I've taken all my strength to explain you in a very proper way by drawing all the diagrams. Nice to see that people are replying me. Good to see people are replying me. In case for the people who joined in the middle and maybe the concept is not totally clear, so what happens is we will even give the recorded session. Once you listen to that again, the concept becomes very clear for you, because if I try to explain this again, what happens is it consumes more time. We need to value the time of other people as well, right? So we are done with the factorial part, guys. Next is very important, which is Fibonacci series and our analysis on that. But before that, we have a small announcement. uh, I would like to hand over my mic to Mr. Kumar, and he has a small announcement for you. And please do not leave the session, because next calculation of Fibonacci series is going to be more interesting, because we need to yet conclude which approach is better, iterative approach or recursive approach, right? I'm handing it over to Kumar, and please do not leave the session, guys. Thank you.
Hi guys, thanks for joining this free session on analysis of time and space complexity. This is one of the very important topic in the data structure. People often feel very tough. That's why from Mercy Technologies we thought of taking this topic and to teach around 1 to 1.5 hour. It would be useful for everyone. Thank you guys for joining. So please be connected. I have one small announcement. Once announcement is completed, then we will start with Fibonacci. Mr. Surya sir, you will be again teaching with programs about Fibonacci. Okay. So the announcement is, so at Mercy Technologies we plan to start one master data structure course. Okay. So we plan to start master data structure course. So we plan to start on 18th of June. So this is the starting date, 18th of June. And the trainer is Mr. Surya sir, who is teaching about time and space complexity. Same person only will be handling this session. I will give introduction about Surya sir later. The timing will be, this will be on daily basis, weekdays, Monday to Friday, because Surya sir is working in a product based company. So he needs to take care of the job also. So this will be, timings will be morning 8:30 a.m. IST to 1 hour. It will be 1 to 1.5 hour. First we'll go with 1 hour, 8 a.m. IST to 8:30 a.m. IST to 9:30 a.m. And it will be on weekdays actually, Monday to Friday. The classes will be on weekdays. So in case if time is not suitable for you, we will be recording all the classes. We will be providing the recording. Suppose people who are from attending, from abroad or outside India, or people who are working. So we will record all the sessions, all the live sessions, and we will be uploading in our website live sessions, and you will be having access. Okay, you will get it. So what is this master data structure course? So the master data structure courses will be containing like complete data structure course. So the, if you ask me the overall hours, how much hours this will be covered. So we are planning is like duration is 2 months. It will be around 2 months, 2 to 2 months around. So total hour, if you see, it will be around I can say roughly 45, no, I can say roughly around 50 hours to 60 hours. So this is the overall, introduction about the course, master data structure. So I mentioned everything. So why you need to go for this course? It's very simple. This course, data structure course, it is not provided by in other institutes. Very few institutes they are teaching about this data structures. I can say like not institute, few individuals who are working in IT, who are working in product based company, they are teaching it. Okay, but the teaching quality might be differ. So I can tell about introduction about the trainer. So the trainer who is taking the class now, Mr. Surya sir, actually he is having around uh, 8 years experience in IT industry. So currently he is working in a product based company. You guys might be aware of it, why data structure is very important. So if you go any product based interview, okay, either you are a fresher level or experience level, if you are going for any product based interview, for sure minimum 2 data structure rounds will be there, right? You guys agree? You can reply. 2 data structure interview rounds will be there, right? 2 rounds of interview with data structure, correct? So there they will be asking, write your own linked list, write your own queue, write your own graph. So what is the time complexity? How you can make more efficient your code. How the code looks like. Consider like how to search particular element in the linked list. Okay, then consider like how to take care of performance of the things. They may ask you, you have 1 crore or millions of records, how you are going to find particular record, which approach you are going to use, which data structure you are going to use, what is the approach you are going to follow for everything. So data structure comes into picture. So what's our plan? Our plan is simple. So Mr. Surya sir, you will be teaching everything in practical. Okay, there is no theory. Everything it will be practical. Everything it will be practical because Jens Surya sir is working in a company, so he is hands-on. Okay, everything will be practical. So each concept we will cover in depth. Will be covered in depth. So end of the course, you should be able to crack any product-based interviews. End of the course, either it is Amazon or IBM or whatever product-based company. So end of the course, you should be able to clear any product-based interview in terms of data structure. You should be able to crack any interviews, right? So you guys might be knowing that in service-based company, they may not ask too much about data structure, but they will ask, might be one round will be there. If you are a fresher, but for a product-based company, I still remember Amazon and all, they will conduct minimum 2, 3 or 4 rounds of interviews in data structure itself.